चलिए ठीक है Ariba, well, the last thing that we were discussing was that we were talking about that alcohols get oxidized, and we talked about primary, secondary, and tertiary alcohols और उनकी oxidation का हमने discuss किया था. How to identify a primary alcohol? Okay, you have an OH group, and that's attached to a carbon chain, which is only attached to on one side with carbon chain and two sides with hydrogen. Okay? And then you have a secondary alcohol that's attached to two carbon chains, tertiary alcohol, three sides carbon chains. Okay, we learned how to figure out primary, secondary, tertiary alcohols kya hote hain, and then the oxidation. We started talking about primary alcohols. Remember only the carbon, okay, the one that is with OH. Uh, that is the one that undergoes all the changes. The rest of the molecule pretty much remains the same. So it's oxidation happening. It's acidified KMnO4 K2Cr2O7 or KMnO4, and you reflux, and it changes into aldehyde, and then it changes into carboxylic acid. From aldehydes, if your starting point is an aldehyde and you're changing into carboxylic acid, then you have two more reagents that could be used. One is toluenes, जिसमें silverines होते हैं. Silverines, they get oxidized to silver, and you also have a Fehling solution which is copper 2 plus. It gets reduced to a copper 1 oxide red precipitate. So these two other reagents could also be used. Then we talked about if you want to stop the reaction at aldehydes, so what do you do? When a reaction continue karega till carboxylic acid. So what you're going to do is, instead of using reflux, use distillation, because aldehydes have lower boiling points compared to alcohols and carboxylic acid. So as soon as aldehydes are produced, they evaporate and they can be distilled off, and they can be taken out of the mixture so that they don't change into carboxylic acids. Okay? So ये सारा हमने किया था, and we talked about secondary alcohols. Secondary alcohols had a carbon atom, where on two sides there's a carbon chain, and this carbon atom would change into a ketone. And that's pretty much about it. Uske baad ketones are resistant to oxidation, they don't get oxidized. And tertiary alcohols don't get oxidized in the first place. So we were doing these questions. So let's practice these two questions. Ariba, what type of alcohol is this one? Is this primary or secondary or tertiary?
Secondary.
Okay, both of them are secondary alcohols, so they would change into ketones. So remember, when you draw the oxidation product, the rest of the molecule would be exactly the same. Everything would be exactly the same, except for these two carbon atoms, that they would change into ketones. So both carbon atoms would change into ketones because they are secondary alcohols. Do the other one as well. इसमें क्या है कि Ariba, what are these two carbon atoms?
Secondary.
Okay, so these are secondary. What about this one?
Tertiary.
Okay, that's tertiary, and this one is
Secondary.
this one is primary. I mean the OH. I mean this particular carbon atom is only attached to carbons on one side. On two sides, they're going to be hydrogens, which are obviously not shown in the skeletal formula. Clear?
Yeah.
Okay, this one getting oxidized. Draw everything exactly the same. I mean the carbon chain at least. So this is your carbon chain. The first part is this carbon atom would change into carboxylic acid. This carbon atom will still have its OH because no oxidation would happen. And the ones at the top and bottom, they would change into ketones. Is this clear?
Yes.
So then you have some other reactions for alcohols. We're going to move forward. There's some other reactions of alcohols. One of them is a dehydration reaction. Okay, we're done with oxidation of alcohols. Remember, it's a very important. You do pele kiya na because it also covers. Uh, but let's do the opposite as well, and that is क्योंकि हमने इसको forward direction में पढ़ा ना, so let's do the opposite as well, which is reduction. Okay, so you can the whole process can reduce, and that is नहीं बल्कि we will do that later. ठीक है, reduction we'll do later. Remember, it's going to be the same chart except in the reverse direction. There's some mechanisms we need to study for aldehydes and ketones, and after that we'll do that. As moving on, it's for alcohols there's a reaction called dehydration of alcohols. Now, in dehydration of alcohols, so in dehydration of alcohols, you have it's basically it turns into an alkene. You have an alcohol. It has an OH group and lots of other hydrogen atoms. This is like an elimination reaction that we studied earlier. As it's like an elimination reaction we studied earlier. So you have an alcohol, and what you do is the OH gets eliminated from one of the carbon atoms, and the H gets knocked out from the other carbon atom, from the neighboring carbon atom. Now, the neighboring carbon atom could be the one on the right, or it could be the one on the left. So you're going to get different products. So let's say the H and OH got removed from the carbon atoms on the right side. So let me redraw the molecule first. So what happened was that you had OH over here and the H over here. They got removed. So if you remove them, it's going to form an alkene back again. So the molecule of an alkene would be formed, and water is going to be produced as a byproduct. So that's the reaction. Or the other possibility is that the H and OH got removed from the carbon atoms on the left side. So there was H and OH here and an H on the left side. So these two got removed. And if you remove these two, the double bond would appear over here, and a water molecule is going to be produced. So this is a dehydration reaction. He gets a simple reaction. H gets removed and OH gets removed from the neighboring carbon atom. And remember, when alkenes are formed, there's going to be a cis version of this molecule and a trans version. Remember to, because it can form cis trans isomers. So this molecule can exist in two different forms. So it can exist as a cis or a trans isomer. So in total, you're getting actually three products. So remember that when alkenes are formed, be careful with cis and trans. The other thing is in dehydration, sometimes dehydration would not be possible if neighboring carbon atom has no hydrogen. Then dehydration is not possible. Anybody, is this clear?
Yeah.
So in that case, dehydration is not possible. What are the conditions for dehydration? The conditions for dehydration are that you would need Al2O3 plus heat, or SiO2 or slash pumice plus heat. That's number one. Okay, that one has, I mean, there's no issue. What you're going to do is you're going to take a, so you're going to take a test tube or a beaker, and you're going to have Al2O3 over here, and you're going to heat it, and the alcohol would be passed over it. So the alcohol is forced on one end, and on the other side you're going to get alkene. So that's how you're going to perform this reaction. And then there's another condition, that's condition number one. Then another condition that could be used is concentrated sulfuric acid. So concentrated H2SO4 could be used as a dehydrating agent. Now that's a liquid. So you're going to bubble the alcohol vapor through, let's say, this is your beaker and it's closed at the top. You're going to put in, I mean, your okay. So your alcohol vapor is coming in, and there is sulfuric acid over here, concentrated sulfuric acid, and alkene is going to be formed at the other end. Okay, that's what's coming out at the other end. Now the problem with this is, using the second set of conditions is that concentrated sulfuric acid is a good oxidizing agent as well. So concentrated H2SO4 can be a very good oxidizing agent as well. Now that creates a problem because so some of the alcohol might get oxidized. It might be oxidized. Okay, so that is going to create some issues because if the alcohol gets oxidized, so the alkene would be contaminated by, uh, it can be contaminated by acidic byproducts. So it can be contaminated by acidic byproducts of oxidation. Acidic byproducts of oxidation, like carboxylic acids. Like if an alcohol gets oxidized, it can form carboxylic acid. And if the sulfuric acid gets reduced, it would form SO2. So these are all acidic gases. So they need to be passed through an alkali. So pass the gases through NaOH to remove the impurities. To remove impurities. Reba, is this clear?
Yeah.
Okay, so remember this. You might be asked why it's being, concentrated. When you're using concentrated sulfuric acid, you might be asked why you're passing it through NaOH. So you're basically trying to remove the impurities that might be produced if concentrated sulfuric acid, instead of behaving as a dehydrating agent, starts acting as an oxidizing agent. So you would need to get rid of the acidic impurities. Okay. So that's dehydration of alcohols. Then the next part is that alcohols can be changed into halogenoalkanes as well. So alcohols, nucleophilic substitution to halogenoalkanes. So you get nucleophilic substitution to form halogenoalkanes. Uh, Now this reaction, there are lots of reactions that can actually do that. I'm going to just give you a brief, very brief description. Like if you have an alcohol and the OH changes into, it gets substituted by chlorine. Now, one way to do that is you heat it with PCl3 plus heat. The other thing is you could use PCl5 plus you could use SOCl2 plus heat, and this apparently gives you the best yield. You could also use concentrated HCl, and that would also do the job. So several different reagents are possible if you want to get rid of the OH, and instead of the OH, substitute it with Cl. Vice versa, if you want to substitute the OH with a Br, the conditions for that are you need red phosphorus plus bromine plus heat, or it could be PBr3 plus heat, or sometimes you can use HBr plus heat as well. And pretty much the same with the iodine, that if you want to substitute it with and change it into Ri, then the conditions are it's red phosphorus, so it's red phosphorus plus iodine, or Pi3 plus heat, or it could be Hi plus heat. So these are all the reagents that can be used for the reaction. Although there's more detail to it, but since there's so many reactions that it's actually impossible to actually remember all of them, and you wouldn't be asked any detail. Most of the time, you're not even asked anything about this. This is not a very important reaction, uh, so you don't really need extra details for these reactions. It's impossible to remember these reactions. So that's nucleophilic substitution to halogenoalkanes. So the next thing is the reaction with sodium. Now it's a very distinguishing reaction actually for alcohols. The reaction with sodium. Now in this reaction, one thing is that alcohols are weakly acidic. Actually, but the reality is they're not acidic at all. The reason why we call them weakly acidic is because they fit the definition of an acid. Because they're such weak acids, they're weakly acidic, even less dissociation compared to water. I mean, water produces more H plus one ions than alcohols. So even less dissociation compared to water. I said the only reason why we call them acidic or weakly acidic is that they produce H plus one ions. The amount of quantity of H plus one ions that they produce is so low that you can't really call them acids. ठीक है मतलब water से भी कम H plus one ions produce करते हैं, so they're really bad acids. Uh, so alcohols very weakly get ionized, which means that the H over here is going to break, and it would form. There's going to be a carbon chain, and O minus one ion over here, and H plus one is going to be released in the reaction. So that's the reason why they are acidic. Why are they such bad acids, and why is the ionization so less? The reason for that is when you have a carbon chain has an electron donating effect. So there's a carbon chain, an alkyl chain. Remember we discussed this when we were talking about carbocations, that a carbon chain has a lot of electrons, so it pushes its electrons to any group that's attached to it. For example, over here there's oxygen attached. So alkyl chains have an electron donating effect. And what that effect does is that the negative charge over here increases. So the negative charge density is greater. Okay, it's much higher. And because the negative charge density is greater, the H plus one would be strongly attracted back again. So it's not going to dissociate. It's not going to break away. Anybody, you get this part?
Yes.
Okay. So remember, acids being strong or weak, it all depends on this negative charge. Okay. But the reason why, for example, HCl is a strong acid. Why is it a strong acid? Because when this HCl molecule breaks up and forms H plus one and Cl minus one, so the reason is this negative charge density over here is probably not going to be very large. So it's not strongly attracting the H plus one back again, which is why once it breaks down, there's lesser chances of it forming HCl back again. Okay, so that's the probable reason. So So it all depends on how concentrated this negative charge is. If it's very concentrated, the H plus one is not going to break away. It's going to get attracted back again, and it would form the alcohol back again. So alcohols are very bad acids, uh, and they undergo just one reaction, and that is with sodium. Uh, Metal plus acid produces salt plus hydrogen gas. This is one acid reaction that we have already studied. Metal plus acid produces salt plus H2. In the case of alcohol, the metals are going to be the highly reactive group 1 metals only. So highly reactive group 1 metals, and for example there is sodium, and it's going to react with HCl. What it's going to do is the H is going to get knocked out and NaCl would be produced, and H2 gas is going to be released, right? And the same is going to happen. The same would happen with an alcohol as well. Okay, so for example, you have CH3, CH2, OH. The H at the end, OHH, is going to get knocked out by sodium, so it's going to form CH3, CH2, O minus 1, and Na plus 1 would take its place, and the hydrogen gas would be, H2 gas is going to be released. And this salt would be known as sodium. If it's made from ethanol, it would be known as sodium ethoxide. So this one is made from ethanol. ठीक है, Ariba, is this clear?
Yes.
So you have sodium plus ethanol, and it would form sodium ethoxide, and that's your only reaction. And another thing about this is that it's a very slow reaction. It's a very slow reaction, and you're going to see very slight bubbles or effervescence. But if you remember, sodium reacts with pretty much everything very, very vigorously. Now, alcohols are such bad acids that even with sodium, the reaction is very, very slow. So only slight effervescence is seen. ठीक है, slight effervescence is seen. So that is the reaction. Sodium plus alcohol produces sodium ethoxide plus hydrogen gas is given off. So then there was a reaction with the formation of esters. Okay. Right now I don't want to do that because vinyl is not here.